Hello, my name is Robert Hart, and this is my presentation for my multi-genre project for English 2089. I've done my project on the effects of global warming on sailing, and I have done that in a package that is a website. And so here we have the home page, we'll have a research page, a diagram, showing kind of how sailing works, a timeline of kind of boats throughout history, just kind of the expansion with boats, some maps, so just kind of like some charts for showing weather patterns, trade routes, that kind of stuff. Navigation, it's going to go through some of the explanations of how navigation is done, kind of an older time with the sextant and like a sailor's almanac, and then currently with GPS, because it ultimately boils down to the same system. And then we'll have a We're Excited page and just an About Me. So starting with the home page, just got a fancy little picture here. Just kind of got this background that's like this kind of thematic with it. So global warming is an increase of average water temperatures as a result of the greenhouse effect. The greenhouse effect basically is gases in the atmosphere, so like CO2, carbon dioxide, even water vapors like H2O, and like methane and those kind of gases. They are in our atmosphere right now, and sunlight will come in and it'll essentially get trapped, and then it will radiate that heat down to the surface. And so this is what global warming is. It's based on the greenhouse effect, and it's just that more heat's getting trapped in because essentially there's more of these gases in the air to trap them. And with more of these gases means it just happens at a faster and faster rate. So yeah, so here's my research. It is just a paper that I have, and it's a Google Doc essentially embedded in the website. So I'll come back to that. So just about me, so kind of just a little bit of background. I'm a third year IT student studying software development and cybersecurity. I enjoy programming and the logical side of it. It's like a little game to me. And I'm passionate about the community. I love hiking. I love all kinds of outdoor stuff, and I've been sailing basically my whole life. Learned to sail in Chautauqua, sail on Lake Erie because I'm from Cleveland, and so I've sailed on this boat. It's a 5-person boat. It's about 37 feet, I think, 40 feet, maybe a little smaller than I don't remember, 4 or 5, and so we do long races on that, and it is my dream one day to participate in the America's Cup. And these are like $2 million boats. It is the pinnacle of engineering. It is just it absolutely fascinates me, and I think it's crazy that these boats are literally just flying on water. So all right, back to research. So global warming, an epidemic, kind of ironic with everything that's happening. I thought that was funny. Maybe not so much, but yeah, basically, the Earth has been changing throughout its life. The glaciers advance and retreat all the time. So the last major one was the Ice Age. Throughout the history, it's been warming and getting warmer and getting colder. Like I said, the last big one was the Ice Age. The last big fluctuation of temperature. And since then, starting since the Industrial Revolution, CO2, which is the primary, I guess, catalyst right now for global warming, those rates have been increasing because we are clearing forests, and that means less and less plants and stuff are able to convert that carbon dioxide back into oxygen. Methane is a lot more potent than carbon dioxide as far as like trapping heat, but it's not as there's not as much of it in the atmosphere, and there's not as much release, but there is still a good amount released from agriculture and stuff like that. So the carbon dioxide is the primary, like I said, catalyst right now, and it leads to a lot of things. So it not only does it trap the heat, so it melts ice caps, it melts glaciers. This melting water raises sea level. This raising sea level causes a lot more flooding. Because of the higher temperatures, there's more water vapor in the air, which is also one of the greenhouse gases. So there's more rain, there's more storms. Because it's getting warmer, it's a longer season for storms to develop, and they're of a higher intensity. And then the CO2 gets absorbed by the ocean, and it causes ocean acidification. So that basically just means that it's lowering the pH of the ocean, and the coral and the ecosystems, the fish, do not respond well to this. So coral will do something called bleaching. So when there's a change, kind of like a shock thing to them, they will release an algae that basically turns them white. And this doesn't kill them, but they're a lot more likely to die in that state when that happens. Um, so yeah, global warming is not a fun thing. Ironically, with COVID-19 and everything that's happening now, there's a lot of these places around the world that are seeing things clear up. There's like the ozone layer hole that was like in the Arctic just got closed up. Then there was like Italy's like rivers really clearing up, and there's a lot less pollution all around, like LA and stuff. It's kind of crazy. So moving on, here is a diagram of kind of how sailing works. So basically you have essentially a sail is just a sideways wing, kind of like an airplane, and the physical concept is that it's a pressure difference. The same air goes over this, but it's longer to get around this part than this part. So the air that takes longer will speed up to try to match its like friend here, and that creates a pressure difference and generates a lift upwards. And that's why like jets are pointed to like blow back this way, because the actual like forward movement is the jet, but the movement of the wing in the air is what keeps it in the air. That's why you don't have the jets facing down like a rocket. The sailboat practice is the same functionality. It's basically the same thing. So when you have those old pirate ship kind of looks, where the sail's like this, that's more of a parachute. The wind's just pushing the sail and it's just pushing the boat because there's not that much resistance in the water. But when the sail is sideways like this, then it acts just like this wing with a pressure difference. This front sail just filters air around the mainsail faster, just accelerates the air, so it just makes the mainsail more efficient. And it does slightly act as its own sail, but it's mostly just for accelerating the mainsail and helping it. This is just to widen it to make it a bigger parachute. And so it's kind of cool with sailing. So you have this, like the wind pushes the sail and it makes you heel over. You have a dagger board, one to keep you from flipping, but also what it does is the same force that was pushing the boat this way is pushing the water this way, and so the two forces kind of cancel out until you're kind of just left straight up like this, and the rest of that resultant vector, that force, is left going forward because you're hitting it at an angle. That's why you can't sail between 45 degrees like directly into the wind. You'll be in irons. So this is kind of like a resultant vector breakdown of how it works here as well. So here's the timeline, kind of showing just kind of how boats were used to kind of just open up the world, because as you can see, the world is primarily ocean. So early on, boats weren't that impactful. A lot of this stuff is all like land bridges, like people are just able to walk, or it's a very short distance to traverse over water, so they weren't that prevalent. This is 43 BCE, Common Era. And so early on, this is kind of just more expansionism with just walking and places. And so this kind of just an FYI. Even though there's nothing in between these two things, that's because this particular map recognizes civilizations. So there are people living, in between these two countries per se, and here and stuff. They just aren't. There's just so many different little groups that they're not a definitive like culture. So they don't have their own like little tile, I guess. It's like an FYI, so to understand why there's gaps. And so here's more just expansionism. This is kind of moving around the Mediterranean. As you can see, this has already been here, but it's just starting to adjust more and more out as they bleed into like the Polynesian islands over by Australia. This is French Polynesia today, or maybe that's over here. It's like the Philippines and stuff, Thailand. And so really starting in 1000, after Common Era, so it doesn't have it, AC, you start to see more expansionism with the boats. You kind of see, starting here in 1492, Columbus sailed the ocean blue. He sailed, and I think he landed here. You kind of, Spain is also branching out and starting to do stuff here. The French go over to Canada, right here. Kind of see this western push, and this is all thanks to, starting in 1450, large wooden boats. became the primary center of transportation. So you've kind of got like the Silk Road that starts to get developed here. More trade routes get developed here. And so kind of the first just claiming these for their empires. And then they start to really just bust through because these large wood ships that started to get made were very heavy and very big, so they could have a lot of people. So they were able to make the long voyage, which could take up to like a year or even longer to just go from here. And now it can be done in like 2 months, or not 2 months, like a month. If you're like kind of know what you're doing on like a 40-foot boat by yourself, you can do this in like a month or two, because boats are just a lot faster and more efficient now. It's kind of the golden age of piracy, starting in the 1700s, like the Bahamas, Bermuda, and stuff. So yeah, starting in 1800, this is kind of when sailing started to become more of a sport. And so it's like they kind of started to slim down boats and make them less about just getting long distances and make them more efficient. They kind of started to figure out some of the physics behind it, make them do better what they do. This kind of started the America's Cup. I think it's like sometime in 1800s, maybe like 1790. At this point, basically the whole world's been mapped out by the 1900s. You've got the World War I coming up. And so yeah, and now it's just bleeding into the next maps thing. This is just kind of like where we are today, well, relatively, 1993. Like established countries, they're not changing much, borders aren't really changing much, and there's tons and tons and tons of trading overseas as well. So here's kind of like to show what I was talking about. So this is an inverse map. So everything in red is a boat's path, and these continents are blacked out. And so the ocean is what you kind of see the continents defined by everything, by all the trade routes. Not as much up here in the northern part. But you've got specific routes in the Pacific, and then you've got the Atlantic routes. You've got around the Cape, Australia, huge stuff with China and Russia. You got India, South America routes, huge shipping stuff here. Here's kind of a simpler version that's just to kind of explain some of it. So the Panama Canal is a big thing, and a lot of ships go through there. Gibraltar Strait, this is out of the Mediterranean to get all to these Mediterranean. So you got like Greece and Italy, and you got like Turkey and stuff. There's a ton of stuff around here. Cape of Good Hope, it's pretty treacherous seas down here, so it's kind of avoided, but bigger shipping things can do it. So the core routes are light blue, secondary routes are darker blue. You can kind of see it. Here's just a way more, like, at any given moment, this is just like a snapshot of all the boats that are like registered, because boats have to register with like essentially a GPS, because there's a lot of like overnight sailing where people just put autopilot on, and so it will make sure that there's no boats like directly in their path. So it's kind of a cool thing. Here's some more maps showing kind of weather patterns. And so here's hurricanes and their typical movement, cyclones more. This is in the European side, and typhoons. Get the westerly winds. So here's kind of more of a little, like the different seasons for them. I think it's kind of cool. You have hurricanes in North America. You've got like the cyclones in Europe, and you've got typhoons over here on the eastern side of the Pacific, or I guess western side, either way you want to look at it. Here's, this is a current. So like all the different currents in the world. So it's kind of another inverse map. It's like you get the Gulf Stream for underwater, and here's more. Just kind of look around. This is the specific Pacific map. So kind of over here, you can see all of the different trade routes on the Pacific. Which is kind of, I put this map in here because all of these maps start left to right, starting as what we would call the western side of ours to this, and so it kind of like has to wrap around, but this is just like that full thing as its own map. Alright, moving to navigation. So navigation happens with a system with latitude and longitude. It's basically a Cartesian plane thrown about on a 3D object. And so you've got latitude and longitude here. The sextant reads you look through this piece, and you you want to set basically the horizon. You want to line up the horizon and the sun by adjusting this, which has a mirror in it. And then whatever that is, number is, you'll use an index to reference an almanac, and based on like the month and the day and stuff, you're able to find your latitude. And this has been able to be found for, since before Common Era, before Jesus, before all that. This has like been known stuff. This has been able to been calculated. The real problem came with longitude, and that's on a 24-hour time zones. So basically, if you know your time and compare it to where you currently are, then you can see how far away you are from Greenwich, England, which is like over here or something. And then that tells you exactly what your longitude is. But that took until the 1800s to find out, made by this. He was originally a watch or a clockmaker, so he made wooden, not a clockmaker, he was a carpenter. He made wooden clocks originally, and then he got into these. And the middle thing is that these timepieces, they'd go on boats, and they were essentially waterproof, and they were made of special metals so that when it got hot or cold, they would expand and contract equally so that they wouldn't throw off the time, because that's the main thing. They could never figure out what time it was because metal would rust, they would heat up, and they would just like break essentially. So this is kind of the math behind how to find some of it. You basically find the horizon, find this, you zero this to get the angle between this, which is like this kind of view. So this is the sun and this is the horizon. So you find what this angle is, which is when you're here looking at the sun and the horizon. And then you just do find some time, you match it with Greenwich, which is like a standardized 0 hour one, and you can find it. Modern navigation is all done on a computer, and it plots, you basically just plot it, and it just does all that GPS stuff for you to find exactly where you are, as well as calculating this as a secondary. These are very expensive onboard computers, but they're hugely beneficial. You don't have to take multiple readings a day. It saves you time. It's a lot more accurate, just all that kind of stuff. Because you even have to adjust for how tall your boat is, for how much above the horizon you are. It's not shown here. So yeah, I think that's about everything. There's a book called Longitude, which talks about these Harrison clocks, so the H1, H2, H3, and H4. And it's a really good read. I'd recommend checking it out. It's pretty short. Yeah, here's my works cited. That's everything.